Welcome to this short recorded solution video involving the activity for the classes of polynomials in the prologue lecture for the Module 4 on computational applications. So this activity is motivated by a few fundamental points. I wrote a lot of stuff in here that's really worth reading. I really encourage students to read it carefully, but I'm going to limit this video to make it short to just what I'm asking you to do with the code. So after reading through this, which I really encourage you to do, the to-dos that you have to do is add missing code documentation for the plot method in both the class docstring and also within the plot method itself. So if you look at this polynomial object, you'll notice that I have a certain style. I'm conforming to the general style, the convention of how you should document classes. So you have these docstrings that describe what the class is. There's some summary of what the class actually is, the attributes that it contains. You list what those attributes are in terms of their types like this, and you also give a little description of the point of those attributes, what they mean, not just their type. And then similarly with methods, their method attributes, you say what they are and return the value. Notice I only have the evaluate. I have init and evaluate. I don't have anything for plot, and I don't have anything for derivative, which is something I'm asking you to do. That's going to be removed as part of the file that's posted for you to work on. I already just have it worked out here. So you need to add the missing code documentation for the plot method in both the class docstring and also within the plot method itself. Both of those things, which means just like you see that I have the evaluate documentation here as a method. Evaluate x, it returns the value of the polynomial evaluated at points x, because evaluate returns the evaluation of the polynomial at points x. This is like a table of contents. This docstring up here is telling you as an overview, here's all the stuff that's in this class. And I don't have any docstring in plot. Put a docstring in plot that looks stylistically like what we're seeing here. It just needs to be made specific to what's going on at the plot command. And then you want to make sure that you also add it as a method here. So that's the first thing you have to do. I'm not going to show you the code documentation. You really need to work on that. I don't want you to just copy and paste. You need to think about the proper way to style it. And I'm showing you the examples of how to do it here in both the initialization and evaluate. You normally, though, with the methods, don't put the initialization documentation as a method because that's something that happens. You're really putting methods that are used after initialization. It helps if I actually spell evaluate correct. Evaluate, there we go, evaluate. Perfect. And let me just go ahead and fix that in other places. Evaluate. That was funny. Okay, evaluate. I have all these. Let's see if I have it anywhere else. Okay. I'll make sure that's all fixed in what's posted. Then I want you to create a new method called derivative. I already have it done for this video just to show you, to make this video really short. But I want you to create this derivative to the polynomial class. It has no parameters, none at all. So the only thing it would have is self, because self is always a parameter it should have. And then self.deriv is going to be, it's a new data attribute that's created in the derivative method that is itself a polynomial object, and it's going to be instantiated with new coefficients that are constructed. The way you do this, I give the details here. The basic idea is this. If I have a polynomial, so I know not everyone has had calculus when they're taking this class, but if I have a polynomial that looks like this, a naught plus a1x plus a2x squared, so on, to an x to the n, then the derivative, which is denoted by p prime, the derivative of that polynomial, is itself a polynomial. It's just that constant a0, a naught, whatever you want to call it, goes away, and you have a1, but then you have 2a2x, and then you would have 3a sub 3x squared, and so on, up to n times a sub n x to the n minus 1. This is just following by repeated application of the power rule to each of the terms here. If you haven't heard about that, I provide links. You don't really need to even worry about what that is if you hadn't had calculus. The basic thing you have to realize is this is the type of code that you need to do. This is the key observation. You should, of course, after you code this up, well, I'll just go ahead and show you the code. So if you're having trouble following those instructions, this is what you do. Derivative, you just pass self. There's no other things here. This is going to be taken out when the file is posted to Canvas. So you won't, even though you're seeing this in the video here, it's not going to be there when it's posted for you. You're going to create a new coefficients vector where I take the previous coefficients and I basically take the length of those and I remove 1, and then I instantiate it as a zeros array, but then I'm going through and saying actually what these are. The new coefficients are defined by the old coefficients times this old order, right? Whatever their index was. But it starts at 1 and it goes to n. Because Python indexing starts at 0, this order goes into the length of the new one, but then I'm just making sure that the first one is now basically the second coefficient that you had before. Again, that seems confusing. Let's just look at this. A sub 0 was my first coefficient for p of x, but a sub 1 is my new coefficient. So this first value when I loop through is 0, and I'm saying what should that 1 be? It should be whatever the index 1 coefficient was, which would be the second coefficient from the original set of coefficients. So that's it. This is the main thing. Once you realize this piece of code, you then create a new data attribute, self.deriv, that is itself a polynomial. So it's referencing back again this class within the class. So the derivative is itself a polynomial. And it just has these new coefficients. And then you could keep taking derivatives of derivatives. In fact, I show some, I think, options in here where I end up taking like 2 derivatives and plotting them in some of these instantiations and code cells that follow. Now, that's the coding of this. So that's basically what you have to figure out how to code. And if you didn't, then hopefully this video helped you. And then the last parts are you should, of course, add documentation related to this new derivative in both the class docstring and also within the method itself, meaning add some information here. You should also add that there's some attributes that are created that are like self.derivs, that this is something that is, as part of its description, added in terms of taking the derivative from the method derivative. You would have deriv here. And then you should also have a documentation in this function as well. So do both, just like I asked you for plot, do it for derivative. All right, so I'm going to take that out though when I have this posted. And now I've provided you with some code cells that follow this class that should then run free of error. These are marked with a comment, instructor created code cell, at the top of each such code cell. So you should not edit any of the code cells where you see instructor created code cell. You should just run these. Then you should work in other code cells and things that follow to create a 4th order polynomial, compute the first 3 derivatives of this polynomial, and create a single plot that contains all 4 functions, where the 4th order polynomial and its first, second, and third derivatives are all plotted. How you do that? Follow the same process that is being shown in this instructor created code cell for plotting the function, a polynomial p, its first and second derivative all on the same plot. I want you to follow that same thing, except I'm going to have you plot the function, its first, second, and third derivatives. That's what I'm asking you to do. So that's it. That's the coding. The coding isn't too much for this, but there's some thought that goes into what you're doing, and I want you to carefully document it and then create your own instantiations of the polynomial and plot it. So it might take a little while because I know that the classes are new, but this is a really worthwhile activity and exercise to spend some time on. Thanks for listening.